What happens when the scanning voltage reaches the set turnaround potential, and why is it important for the experiment to return to the starting potential? How does the potential change during the positive scan, from the starting potential to the turning potential, and how does this influence the oxidation process of the active material in the electrode? What is the significance of the oxidation current generated during the positive scanning process, and what does it reveal about the electrode material's behavior? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does the potential change during the negative scan, from the turning potential to the starting potential, and what happens to the active material in the electrode during this phase? What is the reduction current, and how does it relate to the reduction of the active material during the negative scan? How can the scanning potential in cyclic voltammetry be used to distinguish between oxidation and reduction peaks in the CV curves? How can the peak positions and shapes in the CV curves provide insights into the electrochemical behavior of the electrode material, and why is it important to identify whether a peak is an oxidation peak or a reduction peak? What information can be derived from the comparison of oxidation and reduction peaks in CV, and how does this information contribute to understanding the redox processes occurring in the electrode material? How do the current changes observed in cyclic voltammetry correspond to the kinetics of oxidation and reduction reactions, and what factors influence these reactions? How can cyclic voltammetry help in studying the reversibility of electrochemical reactions in electrode materials, and why is this important for battery applications? How does the data obtained from CV, such as peak current and peak potential, assist in evaluating the efficiency and stability of electrochemical processes in different materials? How does cyclic voltammetry complement other electrochemical techniques, and why is it commonly used to characterize materials for energy storage applications? What are the advantages of cyclic voltammetry in studying electrode materials, especially in terms of reaction mechanisms and the understanding of material behavior under varying potentials? What parameters should be set when conducting cyclic voltammetry (CV) for a system with good reversibility? Why is the open circuit voltage (OCV) typically used as the initial setting for such systems? How does the cutoff voltage relate to the initial voltage, and why is it important to set the cutoff voltage to match the initial voltage in order to create a closed loop? What role does the scanning direction play in the experiment, and how does it relate to the material being tested? How does the nature of the oxidation reaction affect the scanning direction?